we're using FACS to identify different torque values on a joint stiffness of the JIM beam. Today we're going to use it to look at the difference between spectra. So think of the vector of data as simply the spectrum values along the frequency axis, and we're going to compare a baseline with some different spectra that we've collected on two different machines. So FACS always shows the 10 best matches in terms of the SDI value of data that it finds in the archival database compared with the current shape. So that's the whole idea. And what is this useful for? Well, today we're talking about pass-fail testing, but really the FACS bar is going to tell us when it's green that, hey, the data is the same as the data in the archival database, or if the FACS bar turns red and has a low value, then it's different. So we can look at slowly occurring changes, not in the modal properties, but in the spectrum itself, and we can look over any frequency band in an auto spectrum that we like. We can identify specific mechanical faults, specific cases, if we've identified those in the archival database and mark those as a certain case. So we'll do that too later on here. And then for qualification testing, it's a pass-fail of test articles, for instance, in production, or after we've put a machine back online following some maintenance. We can qualify it by using the FACS bars to look at, is this data the same as it was previously, or is it different? And then we can set up a new baseline if things are changed, and then if we're doing walk-around collection or collecting data on a troublesome machine, we can see if it matches up with the data in the database. So we're going to use shape data for that. All right, back to Emiscope. This is Emiscope, and it's got a project open here, and it's got a number of hotkeys. Now, if you're an Emiscope owner, you're probably familiar with hotkeys. Maybe you haven't used them yet, but they are used to execute what we call scripts. Now, these are basically a program. Here's a script right here. Let me make this script large so you can see. These are Emiscope commands. It's a spreadsheet, and each row in the spreadsheet has an Emiscope command, and the command is executed in what we call a target window. So here's a target window name. These are different names. The Emiscope window itself. Here's a window called acquisition aerial compressor. That's the name of this machine we're going to look at. Here's a BLK that has measurement sets of spectra in it. So we're actually going to compute those. Here we're going to clear them. Here's a command that says select all the measurements and then delete all the selected measurements. So that's what those two commands are going to do when this executes. And then we have a shape table called temperatures. And again, we're going to select all the measurements in the shape table, and we're just going to select them. Well, we're going to select 1 and 2. So down here are some parameters that go with that command. Let me make this a little bit larger. And you can see that we're going to select, here's a description of each of the commands. Selects measurements by number. We're going to select measurements number 1 and 2. And then we have another command here that's executing in this same window. This is called a Vibrant script language window. This is a script language, and this one is called Make Spectra. So what we're going to do when this script runs is we're going to make some spectra. And how are we going to do that? Well, first we're going to set up measurement sets, and each measurement set is going to be a set of spectra. Now we go to the acquisition window that can post-process this data, and measurement sets are something we use in the acquisition window. A measurement set is just all of the data that's been acquired at the same time, been sampled, been filtered, been processed, post-processed. In this case, we're going to compute spectra from some time records. Okay, we're going to tell it to start, and then we're going to, and when it finishes, we're going to go to the lower graph, and we're going to select the spectra 1 through 12. Those are the measurements, and you can read over here a description of each of these commands, and then we're going to save those. So we select 1 through 12 and we save them. Where do we save them? Into something called measurement sets of spectra, and we're going to add them in there. Now remember, up here in the beginning we cleared out everything, so we cleared the data block, and then when we get down here where we save them, we're going to start adding these measurement sets of data into the data block called measurement sets of spectra. Then we're going to save the temperatures. You can see over here the label that tells what's going to happen here next, and these are things that I can type in wherever I like to describe this program or this script. Okay, so we're going to turn the active graph to the upper graph in the Aquin window. That's where the time records come in. And we're going to select 13 and 14. So there are essentially 14 measurements that are being acquired by the acquisition window out of a data block. Well, how do I know that? If I go back up here, connect to the front end. So I can either connect to a hardware front end. In this case, the acquisition window is connected to another data block, something called BLK, low speed steady state, and that's some time data that was acquired. If we used Emyscope in a portable carrying case as a smart data logger, we just collect that data and store it in a database, store it in an Emyscope project. Anyway, let's go back down here. So what we're going to do is select measurements 13 and 14. We're going to set up a band cursor between 25 and 75% of the window of data that has been acquired. So that's just to pick some data out of the middle, and when we do a select a measurement set, temperatures. Okay, this is going to select a shape that corresponds to my measurement set. So measurement sets are going to go 1, 2, 3, 4, 5, and this is a parameter, and we call these global variables. I'll have to show you where we set those up, but we're going to save shapes. Now here we're saving the band cursor data in the band of a time record, and what it saves is essentially the average value of the temperature over a time span. Then we're going to come down here to the bottom, and this creates a loop. So this is what we call a global variable, and you can see that we're in our window here, and if I read over here, it says measurement set equals measurement set plus variable 3, which is a 1. So this is incrementing the measurement set from 1 to 2 to 3 to 4. So this is a little bit of programming. And here we've got an if statement, and it says if variable 1, the measurement set, is less than variable 2, which is a 5. In other words, as long as the measurement set is less than 5, go to, if true, go to a step label, and the step label is called next measurement set, right up here. So this little program is going to run in a loop and create 5 measurement sets of data. And then it renumbers the measurements when it gets done, and it says it turns off the cursor in the measurement sets of spectra. So let's go ahead and run this and see, and you'll see there's a lot of things going on here that this one script. Now, each script, when I create a script, Emscope will also create a hotkey that will execute that script. Now, I can either use hotkeys or I can just run the script. I can do a lot of different things, but typically I want to use a hotkey to execute the script. So let me go ahead and press this hotkey, and you can see that it's doing some acquisitions over here. This is the acquisition window. Now there's a lot of things going on in that acquisition window. I'm converting the accelerometer data to velocity. It's doing integration. It's converting the temperatures from centigrade to Fahrenheit, something that we Americans are more familiar with. And then down here, what it's done, here's my original data right here. And I can run this as many times as I like. So if I press this again, it'll start over. And this is a data block with some data in it. Let me see how many traces are in here, or how many measurements. There's 14. And you can see from the properties here that the first 12 are accelerometer data, the last 2 are temperature data, and they're in degrees centigrade. And so this, and then the acquisition window is acquiring data out of this data block and post-processing. So let's take a look in here and see what it's doing. Quite a bit of stuff. Okay, so here's the 14. I'm looking at my upper traces. Here's some data coming in from the data block, and you can see that it's already integrated it to inches per second, and it's converted the centigrade to Fahrenheit. So that's going on here, and I set that up over here in the channel spreadsheet. You can see that it just did, this one is set up for measurement set number 5. There's actually 10 that I've defined in here, but I'm only going to use 5 of them. Down below here are the spectra that were created from for this particular case of the 12 accelerometers. And you can see that they're all in here. So when I run this thing, let's just go ahead and run it again. You can, once you have this set up, you can run it as many times as you want, and you'll see that it's grabbing data out of the time records down here up into the acquisition window, and then the acquisition window is saving that data into a data block down here. This is the vibration data, and over here is the temperature data. So acquisition kind of sorted everything out. Let's look at what's in here. Okay, I've got a bunch of traces in here. They're auto spectrum data, and there's actually 60 measurements. We use the word, we used to call them traces, now we call them measurements, same thing. These are auto spectra of this vibration data. Okay, so I've got, and you can see that they each have a measurement set associated with. So the first 12 are measurement set 1, and then from 13 down to 24 is measurement set 2, and so forth. So these are 5 sets of data, each set with 12 spectra in it. Let me run that one more time, and we're just creating new data here by walking through our time records, which is a very long time record, and I'm basically starting over each time I do this. Now the temperatures are being stored down here in a shape table, and they're going to be used by the next set of processes that will actually take them and put them into a shape table, which we archive into a database. Now I've got some other hotkeys up here. I can pick a new baseline spectrum. I can connect to the archive. I can disconnect. And then I've got some other hotkeys that I'm not going to use here because those scripts are going to be called by this script over here, which says import next measurement. So let me push that one, and that's going to simulate taking a data block of data out of this block here of my 5 measurement sets and either logging that in. First we're going to post-process that data, and then we're going to log some information into the archival database. So let me go ahead and push this one, and we see that it did a whole bunch of things. The first thing it did was arrange all the windows differently. So let me make this large. We'll take a look at this. When I pushed that hotkey, it ran this script right here. And the first line in the script says, call another script called arrange windows and run it once. So this is like a subroutine. And then it said, do something with a global variable. In this case, it's the measurement set. And it said, increment the measurement set. Well, I'm not sure what the value is set to right now, but I've got 5 of them, and it will increment. And as long as the measurement set is less than 5 or equal to it, it's going to go to import UFF. So this is a simulation of importing data from a UFF file. In this case, we're not going to import it. We're just going to run this script down here called import UFF, and then we're going to correlate the spectra that we pull in for this measurement set. Remember, we got 5 of them here and 12 spectra in each measurement set. We're going to correlate those with a baseline. And up here I can push this button and that will give me a new baseline. So all that does is take the data out of the spectrum data block that has the 5 measurement sets, and it sets aside one of those sets as a baseline. So let me go back and run this again. Now what happened from all this post-processing is this shape table right down here. Let me make this large and we'll take a look at it. And what we've got in here are what we call an engineering data shape. The first 12 measurements are SDI values and MAC values. And this is a standard command in Emyscope where what it's done is taken the difference between the baseline spectra and the current spectra for this measurement set, and it's stored in here a value of the modal assurance criterion, that's shape number 1, and the SDI, or the shape difference indicator, and you can see that they're all around 100%. So what this is saying is the current and the baseline are almost the same. And then down below here we got the inboard temperature and outboard temperature. Well, where do those come from? Well, we need to go look at the 3D model to see, but you can see they're set in here, and they're the same for both the MAC and the SDI. Now this data is the data that's being archived into the archival database, and then we're going to go over to console and we're going to take a look at it. So let's go ahead and do that. I'm going to, well, let's just run this one more time, and let's connect up to the, okay, it says connected to the archive. That ran this little script right here, which connected to the archival database, and it also set a value here, a parameter value. It set the value of a global parameter called connect to the archive, and it set it equal to 1. Where do those come from? Well, if we go up here under script and we go to variables over here, well, let me see, I want to display, here's where I define the hotkeys. I don't see those variables, but anyway, one of them is in fact called connected to archive. So if I push that hotkey, let me go back to my hotkeys, connect to archive, it's going to say I'm connected. So now when I run this, hotkey that says import next measurement, it's going to rattle through a lot of processing and archive this shape table as well as the spectra for this. And you can see that there's a band set up here. So I'm only comparing the spectra in a band from 1,000 RPM to 3,000 RPM. And that was set up with a script command also. So if I run this again, you can see that it'll put those bands back there and just compare the data in the band. So I can move this band anywhere I want, make it as wide as I want, especially if I'm looking at bearing problems. I can look at the second and third and fourth order and compare a baseline spectrum with the current spectrum. Okay, so this is all working the way I want it to. I'm going to put this aside for a minute, and I'm going to bring up the console, because the console, and here's this machine in the console, and this stands for aerial compressor walk around data collection. And I can see that this one is connected to Emiscope, and I've got the same hotkeys here that I was using in Emiscope. Not all of them, but a couple of them. One says new baseline and the other says import next measurement. So if I run this, it's going to go to Emiscope. Let me put Emiscopes up so you can see that happening here. I'm going to set Emiscope over here on the side. So I've got console on the left, Emiscope running on the right. Let me push the button here from Emiscope and it'll rearrange its windows and run through and put some new data into the database. Or I can run it from the console side. So this is the advantage of these hotkeys. When I'm using an archival database, I can store data in and remotely run Emiscope in a box or remotely on my computer to do the processing. So we call this Emiscope running under the hood. If I double click on this, now I'm getting, let's go back and look at a trend plot of my data. Here's the data coming in. Now this is the SCI data or the MAC values. Remember, my shape table is just some engineering data, and here you can see that they're well, this is the wrong machine. I want to go down here to this machine and open up what we call gauges. So here is the data that's coming in from Emiscope, and I have a gauge for each of the values, and you can see they're all pretty close to 100%. So I've set up some warning levels on these values, and they're all green. So I'm getting good numbers from the MAC values or the SDI values. If I look at the model, well, let's make this large so we can look at a lot of stuff here. Come on. Well, maybe I can draw this over. Mouse over any of the icons that show where the data was taken on this machine. There's a temperature. A little hard to see some of these labels. We can make them a little larger. Let me see if I can do that under gauges, and we'll make them, I don't know, 150, 140%. Now you can read them a little better. So I have, well, frequency is not interesting to me, but I've got SCI values or MAC values for this data, and you can see the trend plot here. The values are going to be between 100% and 95%. If I go back and press a hotkey, it will go back to Emiscope and get some more data, and we'll see it come in here. Basically, that's simulated opening a UFF file and pulling in some more data. And down here, I've got two fax bars. One of them is showing my vibration, and it's saying that these vibration levels measured by SDI are all the same as what you've got in your database, and the temperatures are all the same. So as I take data, basically this is my pass-fail test. It's saying this data is coming in exactly the same. So that what that means is that the spectra, now here you can see the spectra all changed at 99. What are we looking at here? Well, let's go and look at our definition, define the bars. And here's how I've defined them. I've got one called vibration, one called temperature. If I look at the definition, here's how I've defined vibration. I'm pulling data out of my short-term storage. That's where Emiscope has logged it in. And I'm just grabbing the vibration part of the shape for SDI. So we're not looking at MAC, we're just looking at SDI values here. Now if I go to the temperature bar, here's the temperature bar. It's pulling data out of the short-term memory, and it's just looking at inboard and outboard temperatures, again for the SDI shape. There's two shapes in the shape table. You can see them here. There's a MAC shape and the SDI shape. Now here's where we can change the sensitivity and start to distinguish these 5 cases. Notice up here there's another little message up here. When I press this button each time, Emiscope's going to send me this message and tell me which case it actually ran. Remember, there's 5 measurement sets of data, or 5 cases. So there's case number 5. Now let's go to this measurement. Let's go to our vibration here. You can see what it's using to calculate SDI, and let's crank the sensitivity. I'm going to crank it all the way to 10. Now remember what sensitivity did from our slide. That moves all of the shape values closer to 0. And that will make that SDI calculation much more sensitive. Let me update this. Okay, it didn't change a whole bunch, but you can see temperature. Now it didn't affect the temperature change at all. We can do the same thing for temperature. So let me crank that to there, and see it didn't change much. So those temperatures are pretty consistent. Let me also just hide the temperature, and we'll just look at vibration here for a minute. I hit a display button and I updated the display to show the temperature. Now let's walk through and take some more data from Emiscope and see what happens to these fax bars. See, now we've got 2 cases in here for case number 1, because we've been pushing the buttons enough, but these down here are 82%. So we got some other data in the database that's quite different. And what that's saying is that these cases are all not the same, even in that narrow frequency range of the spectra. And it's comparing all 12 spectra baseline to the current. I'll walk around the loop here and we'll see how they all compare. Well, those are the same. Case number 3, very similar to what I've already stored in the database. Number 4, very similar. And Now the database is full of a lot of these different cases, so all I've got down here is the date when they were put in. So let's go back here and let's clear out the database and see how different these cases are. So I'm going to delete the short-term archive for this machine. Now let's go back and look at, we should get, okay, we're empty because there's no data to compare. So now I'm going to go ahead and archive case number 1. And there was nothing to compare yet. Got case number 1 in there. Now we're going to archive case number 2. Okay, well, case number 1 and 2 don't correlate. Only 82%. That's the SDI value. Case number 3. Okay, well, this is 89% and 77%, so those don't correlate real well. But you can see how I can control the sensitivity, and now case 4 correlated very well with data that I had previously archived into the database. All right, let's switch over to a different machine now. And here we're going, we've got case 5, and now we're back to case 1, so we've got all the cases. And now we can see that case 1 didn't correlate very well with the other 4 cases. So there is some difference in those spectra. Let's go look at a different machine now that is set up exactly the same as the aerial compressor, only it's a hammer mill. And it's got its own VTPRJ, its own project with the same type of processing in it, the same set of hotkeys, and I'm going to open that. Let's just put this guy back here, and we'll see that when I click on this to open, it's going to open a different project, and it will open the project for that machine. Okay, so here it comes. Emiscope is opening its project. Same situation, but with some different data for this machine. And now it's connecting to the database, and through the database, it should come back here and tell me that I've got this machine online now. And now this one's still online. It thinks it's going to receive some data. It's saying the machine is online. However, it's been closed. Its project's been closed, and Emiscope's been open on the hammer mill. So let's make this go back large, and we'll double click on the hammer mill, and we have a similar type setup here. Let's go look at the model. Here's our model, and you can see it's all in the green. That means that the current data is matching up. Here's our gauges. The gauges, in this case, we're displaying gauges in a different format. Here's a trend plot, and you can see the values for this machine. Some of the values go way down here to 0. So we're going to see some big changes in the SDI values for this machine. Let's go, and I'll go back here and display everything together so you can see it. And now let me go push the hotkeys for this machine. Same hotkeys, but now they're applied to a different machine. And we'll see as the data comes in into the database, we got still, it's very close to 1. So the gauges are all showing green. And let's just go around the loop here and see if we get some different data. Still 1, Gauges are still green. Here's the vibration of the motor, and here's some vibration on the bearings of the hammer mill. Let's go again. Now we got to change. See, the gauges dropped because I've got warning levels set up. Let's just go look at the warning level here. Let me remove this temperature. I'm going to look at the gauge settings for one of these gauges. Now they're set on default, and here are when the values drop 10, 20, or 30% below the baseline, or they go above the baseline, we're going to change color. So what this is saying is that the SDI value dropped 20% or over 10% below the baseline, and that's why it turned orange or yellow. Let's do it again. And we can actually see over here on the model which of the gauges has changed. So now we got a drastic change, and what this is saying is that the spectra for this case are quite different than our baseline spectrum. And so the SDI values are very low here. And let's go look at the FACS values. I'm going to make those large. And let me turn off temperature for a minute because it's not showing any change. So we'll just turn off the temperature. And here is the case for, you can see I already have some data in the database that corresponds to this case, and it correlates very well, but then a lot of the other data doesn't correlate very well at all. This is the top 10 correlations of data in the database with the current data. Let's go back and do the same thing. We'll go here and clear out, delete the what we call short-term data. So now if I run this thing again, and case 3 is coming in here. We got the same 5 cases coming in, and okay, well, I don't have any data in the database, so no FACS bar. Okay, so that is showing me that this particular case, that's 100% or 99% the same. 3 and 4 are the same because 3 was already in the database. And now we're going to 5. 3, 4, and 5 are very similar. Well, case 1 is different than what's already in the database. And then we'll crank the sensitivity on these again too to see what happens to, boy, that one there, that case didn't correlate with anything in the database. So that was the case where we saw the gauges dropping. Let me go, we can go look at the gauges, and you can see they're all red for the Mac, and for SDI are all red. So this is saying that we just made a measurement out on that machine and imported its data, and it's totally different. Okay, so here we got back to case 3, and it correlates very well with what's in the database. Now, we can actually identify these cases by going back to the trend plot and labeling them. Since we only have 5 cases here, and this would correspond to, let me just do this, and let's make our trend plot large here, And let me see if I can do that. Come on, trend plot. Why aren't you? Well, here's another way to do it. I'll just close everything and trend plot will get large. So if I go back and look at, we have another table in here called an event log. And it's full of things. I'm going to clear this event log out by clicking on all these events. And what we're going to store into this event log are each of the 5 cases. So if that case ever comes up again, we will recognize it as a particular fault on the machine or particularly good data. We can do that. Or a particular configuration that the machine or the structure might have had that we've identified. So if I go back here to the hammer mill, well, let me put this down and make this one large. Come on, you're not being cooperative. Put that down. So what we're going to do here now is run the hotkeys and identify each of the cases. So case number 3 was the last one that came in. Let me press this again and we'll see which case is coming in here. Should be case number 4. Now I'm going to go over here and I'm going to right click on this data and I'm going to create an event. You see this little window came up here and I'm going to type in case 4 and I'll add that. Now that went into my event log. So let's go back and look at the event log and see if that in fact happened. Okay, so here it is. Case 4 was that set of data, that shape data and the spectrum data that also got archived. We haven't looked at that, but let's just go ahead and call for some more data from MeScope. You can see this thing is completely network based, so that I can have it, the database in the cloud, I can have it on a network. MeScope can be remote, taking data, and or it can be just used in a, like I'm using it here, in a computer. This is case number 5. And we'll just do one more here, and then we'll see if FACS will identify those particular cases. Okay, so here is, this one is case 1. Case 1. What we'll see here is that it's kind of a unique pattern recognition. We're also getting some warning levels exceeded, so it's putting in another event. So we're going to delete that, and we're also going to tell it enable event logging. So we're going to turn that off. See, I turned that off, so it's not going to put an event in every time one of my gauges turns yellow or red or violates a warning level. Okay, so let's go back and go back to my, okay, well, I've closed my FACS window, so I got to open FACS again, and let's close this guy. Yeah, I'm having trouble seeing everything here. So here's FACS. Okay, well, we had closed the temperature. Let's, he should not be displayed there. Temperature. Oh, that's not it. Okay. So now what I'm going to do is switch over, and rather than use the short-term storage, I'm going to use the event storage. So I've identified certain events, and now I want to run this and see. Okay, so it immediately identified case 1, case 5, and case 4. They're all very similar. So let's just run this thing a few times and see what happens now. Case 2, and how well does it identify? Okay, so I only had case 1, 5, and 4 in my database. Case 2 didn't correlate at all with any of those cases. Let's do it again. So this is really simple statistics. Here comes case 3. Case 3 correlated very well with the 3 events that I had in there. You can see case 1, 4, and 5, very similar, even though and here's case 3. All right, case 4. Case 4 it identified. There it is. Case 4 is a 1. That means this is exactly the same data. 0.99 like 5 and 0.95 like case 1. So case 4, now case 5 should come up with a 1. So this is how we can use event storage with facts, and there it is. It's identified case 5, and see, these are in order. So this is the highest correlation, the next highest, and then the next highest. Since I only had 3 events identified, it's always going to use those. And then case 1 just doesn't correlate with any of those. Oh, yeah, case 1 did. Case 1 was in the database, so case 2 was not in the database. Or even if it was, did it correlate well? No, it didn't correlate well at all. Case 3 was not in our event storage. And it correlates well with 4, 5, and 1. All right, that's all I wanted to show you today. We are at the end. Mark, are you online? Did we have any questions we can answer?
We don't have any right now. If you do have some questions, feel free to email them to us, and we'll get those answered for you. Let me just go ahead and unmute. If you do have some questions you can ask them now, or you can email them to us at sales@vibetech.com, and we can respond to you via email. We are video recording. We did record this entire webinar, so we'll be getting this up on our YouTube site, which is at the Vibrant Technology YouTube channel. And we'll also go ahead and post a copy of this to our Facebook site as well. So we'll have that probably up here in probably in 2 days or so.
Any questions? Okay, now these scripts with the hotkeys are available as Emiscope projects, so we can provide those to anyone who may have a question or want to run them. Now you're going to have to install our MSS software and archival database. Those are available, and we can get you set up to do that, and you can run this entire case.
Yeah, no questions at this time.
All right, well, we'll wrap it up for today, and we'll talk to you next month. So thanks for attending.